Okay, so thank you very much. My name is Jiamou Liu. I'm from the University of Auckland. So I work on a range of topics. One of the topics that I work on is complex network analysis, which is, so complex networks is prevalent in all sorts of natural and social sciences. Needless to say that it's very, very important, as it has attracted many research in the recent decade. One of the very obvious properties of complex network is the community structure. So we know that a complex network are not just uniformly randomized linked. So all these nodes, they tend to form densely connected clusters, which are not densely connected between each other. And one of the main effort in analyzing the network structure is to understand what sort of community compositions are contained within these networks. So I've been working on this question for a while, and then we can view a network data set as the outcome of a combination of certain laws of nature that are rather determined, and then some inherent uncertainty. Right. And the goal of the data analysis algorithm, such as community detection algorithm, reduces the amount of uncertainty within the data set. And therefore, the question would be how much information is gained or how much uncertainty is lost through this process. Right? So that's the question that we want to ask. And in fact, this has been a very important question since the time when Shannon proposed his measure of information content. There are already questions floating around about quantifying the amount of uncertainty within structures. And in fact, this has been proposed as one of the great challenges in computer science in the new century. So we take this question on, and in order to quantify the amount of uncertainty lost, we first of all look at the graph, and then we'll try to somehow represent the graph and compress the graph. And then the representation is, what we can do is just to list the edges one by one, and each edge consists of two nodes. And then we can choose one of the variable length losses encoding, for example, just a Huffman encoding, to encode the graph. And this will be, giving us some representation. And then if you look at this encoding, you can actually quantify the information using Shannon entropy of the degree distribution of the graph. But what if now you impose a community structure on it? So when you have the community structure and when you explicitly know what the communities are, you can somehow do these local encodings. So you just need to encode the node within the communities so that you don't have the entire set of nodes to encode. And then so basically, you can have a sort of a tree-like hierarchy to encode the structure. And in this way, this will give you a reduced number of bits, right? And that's quantified in this, in this formula here. I'm not going to go through the details. But what are the actual goal for us, right? So one of the applications that we look at is community deception. So there, we were looking at the disclosing of community structure as a type of privacy leakage and should be avoided. And we want to somehow add noise so that to disallow the community detection algorithm to accurately detect the communities. And we do that through actually using these entropy measures for the, the structure entropy. I have no time to go through that, but basically we've invented an algorithm that efficiently solves the task. And then more recently, and so this is actually unpublished, but we're looking at the other direction, which is to detect community using these structure entropy notions. So we basically embed the structure entropy as a loss function in the graph convolutional networks. And then we've actually obtained some very promising results. But of course, like what I said, we haven't really finished that we haven't really get it published. This is a work with my student. And lastly, I just want to do a sort of a promotional slide to promote my students. So we got quite a number of students in my group who are here, who are presenting their research in the poster session, so do pay a visit to them. Thank you very much.